Good morning, Year 10s. Over the last couple of weeks, we've been focusing on rates of reactions. And today, after looking at your quiz results, which were generally very, very good, I just want us to just make sure that the most important things have gone into our head. To do with the quiz, it's quite clear that some of you are trying to do it without looking at all the videos very, very carefully. I'm doing it on purpose. I'm putting in one or two questions that are showing me if you are listening carefully. So please don't get caught out. From the quiz results, one of the questions that was seemed to catch a few people out was the effect of concentration. When we talk about concentration, it's the particles. Remember I spoke about if I go to a nightclub and there's lots and lots of people on the dance floor, I have a high concentration of clubbers on the floor. If I have lots more particles in that same beaker, I have a higher concentration. And because there's more particles, there's a greater chance of a successful collision. So that's the link you've got to make with concentration. It's about the number of particles. With temperature, it's about the energy. And if those little particles have more energy, they're going to zip around like crazy and there's going to be more chance of a successful collision. Couple things about enzymes. The trick question that you had to listen to was it was the enzyme pectinase that turns cloudy fruit juice clear. And make sure that you remember that enzymes can be reused, and that means that they're unchanged during the chemical reaction. And that's why on one of the questions it was looking for your understanding that the mass will remain constant. So it was a graph that had a horizontal line because the mass remains constant in terms of the catalyst throughout the reaction. So excellent work, and each time it gives you an opportunity to see how much you're understanding, how much you're getting in, and how much is sticking. Now, talking about stickability. Today, in this session, we're going to do a little retrieval exercise, and that's basically to test your memory on some of the key points. What I'm going to do, I'm going to ask you a question. I want you to pause the video and take a few minutes to, on the next page in your book with the heading Rates of Reaction Revision, I would like you just to write the bullet points. This is going to give you an opportunity to see what are the bits that are sticking and what are the bits you need to just work on that little bit more so that that memory post-it note sticks in your head rather than falling off. Okay, so the first question. Can you list the 4 factors that affect the rate of a reaction? List the 4 factors that affect the rate of a reaction. Pause the video and start when you have the answer. Let's check your answer. So do you have the temperature, the pressure or the concentration? Those two go hand in hand, pressure or concentration. If you just put concentration, that's fine. Just in purple pen, add pressure. The third one, the surface area. Remember, the larger the surface area, the faster the rate of the reaction. So to get a large surface area, I crush that vitamin C tablet. So powder equals large surface area. And the fourth one is adding a catalyst. How did you do? You got it wrong, not a problem. Just purple pen it. That is how we learn. Okay, second question. Can you list 3 different methods to investigate the rate of the reaction? Again, pause the video and start when you are ready. Okay, so for this one, I think trying to remember the diagrams is really helpful. The first one we did was the cross on a piece of paper, and we used that method for when a solid appears during the course of the chemical reaction. So you've got two liquids reacting, a solid or a precipitate is formed, and the cross disappears over time as that solid is formed. That's the first method. The second method is when you collect the gas either by using a gas syringe or by using an inverted measuring cylinder with water, and then as the gas bubbles through it, the level of the water drops down because the gas displaces the water. So we obviously can only use that if a gas is produced in the reaction. The third method for investigating rate of reaction is got to be the balance scale. That's right. So if you have a solid that is during the course of the reaction disappearing, it's turning perhaps into a liquid or a gas. It's got to be a gas actually. Or for example, the classic examples, if you're using chalk or calcium carbonate, marble chips of different sizes, as the marble chips is reacting with the acid, it's going to form carbon dioxide gas, and the mass is going to decrease because that gas is able to escape. So using a balance scale, again, if you've got a solid, usually a substantial solid like a marble chips is the classic example. Okay, well done. Question number 3. What is the collision theory? Pause the video. What is the collision theory? Now this is really important because actually all the answers related to rates of reaction and the factors all take into consideration the collision theory. So you've got to say that the collision theory is saying that the particles need to collide with the right amount of energy. So if they just go like this, nothing's going to happen. They've got to collide with enough energy, and they've got to collide in the right orientation. So they've got to collide in the right direction. They can't just slide past each other. They've actually got to bang head on. Okay, the right energy and the right orientation for a successful collision to occur. So that's why when we say when we increase the temperature, the particles have more energy, and therefore there's a greater chance for a successful collision. When we have more particles, there's more particles to collide with, and therefore a greater chance of a successful collision. Those are the keywords the examiners are looking out for with beady eyes. Okay. Question number 4. If we're measuring the average rate of a reaction, what is the unit that we use for measuring the rate of the reaction? Pause the video and then start when you're ready. Okay, so for this question, you have to remember that you're either looking at the mass of the product produced or the volume of the product produced over time, or alternatively, the mass of the reactant that is lost over time. Okay, so because it is mass over time, if we got a solid in the reaction, it's going to be grams per second. If we've got a gas, it's going to be volume, and therefore the unit is going to be centimeters cubed over time. Remember, centimeters cubed is the same as milliliter. For some reason, our scientists like to make things a little bit more complicated. Centimeters cubed from maths, length times width times height is the volume. Centimeters cubed over time. Last question. What I would like you to do is I would like you to draw me a graph to show what the rate, how you would see the rate of the reaction on the graph if you have three reactions, one with a large surface area, one with a medium-sized surface area, and one with a small surface area. So on your set of axes, you are going to draw me three curves, and you need to tell me which one is the one with a large surface area, so the powder, which one has a medium surface area, and which one has a small surface area, so that I can see that you can understand the difference between those. Pause the video and restart when you are ready. Okay, how did you get on? So for this particular example, I'm not going to do a fancy graph on the screen, but your graph could be one of two different graphs, depending on the reaction. So I'm just going to very quickly. So if you look at this reaction here, if it's a reactant where I'm actually measuring the mass loss, the curve is going to curve down this way. If I'm looking at, for example, the hydrogen produced in a reaction, or the carbon dioxide produced in the reaction, the level's obviously going to increase, so the curve is going to look like this. Now obviously from these, the steeper the gradient, that's what I'm looking for. The steeper the gradient, the faster the rate of the reaction. So in terms of particle size, the larger the surface area, in other words, the more powdery it is, the faster the rate of the reaction. The smaller the surface area, the slower the rate of the reaction. And that's why the gradient is less steep. What's also really important, because I'm doing this as a control variable, everything's staying the same, the mass of the marble chips perhaps, the volume of the acid that I'm adding the marble chips to, I'm going to get the same amount of carbon dioxide produced. So all of these graphs meet at the same point. That's also really important to show. Unless I suddenly double the amount of calcium carbonate, then the height is going to go, it's going to double. Okay, so that's really important. The only thing I'm changing is the only thing that I'm changing is the speed or the rate at which the reaction is taking place. If you have any questions, please email me. As a bit of a gift, I've created you a mind map of rates of reaction that maybe you can stick in your book, and it will be a summary of the whole topic that we have done. So don't lose it. If you need to add little things to it over time, mind maps, your revision notes are always working documents, then please do so. Brilliant work, and I look forward to seeing you in our next section, part 2. Very, very well done.